Good morning, dear students. Welcome to Jatin's Academy. So, today in this class, we are going to start with the fourth chapter of Physics, Class 6 ICSE, that is Energy Simple Machine. So, in this class, we are going to study that what are machines, that is functions of simple machine. Then we will see about terms related to simple machine. Then we are having types of simple machine. In the types of simple machine, we will discuss about 6 types of simple machine. First, we will see about lever. Then we are having inclined plane. Then we will see about wedge. Then we are having pulley. Then we are having screw. Then at last we will discuss about wheel and axle. And then at last of the chapter we will discuss about the care of machine. Now let us start with the chapter. So first topic we are having of the chapter machine, that is what are machines. As the name suggests of our chapter, that is machine, energy. So what do you mean by machine? Firstly we should know the definition of machine. So whatsoever things we are using in our surrounding, for example we are using hammer, we are using knife, we are using bottle opener, or whatsoever things we are using in our surrounding that makes our work easier and faster. For example, here if I am having an apple, here I am having apple. If I want to cut this apple, if I want to cut this apple by applying the force by my hand, can I cut this apple? No. Obviously no. How I can cut with my fingers or with my force from the hand? So if I am using here knife in order to cut the apple, in order to cut an apple, so it is very easy to cut an apple within few seconds only by applying the force by knife. So the instruments which are making our work easier and faster, that instrument or devices are known as machines. Okay, and machines which are manually handled means whatsoever machine which we are using, we are applying some kind of force in order to move that machines or in order to take the work from that machines are known as simple machine, or simply you can say the machines which are made up of only few moving parts, only one moving part, that is known as simple machine. For example of simple machine we are having like hammer. In a case of hammer, not that much kind of machines are connected and then a hammer is made. No, in a hammer simply one arrangement is there by which we can easily fix a nail into a wall, or whatsoever work we want we can do easily. Okay, next we are having screwdriver. So screwdriver is also acting like a machine which makes our work easier and faster. Next we are having knife. As I told already the example of knife, that knife is also acting like a machine which makes our work easier and faster. Next we are having bottle opener. So in order to open the bottle opener, in order to open the cap of the bottle, it is very difficult to use by in order to open it by hands. So by simply using the bottle opener, within the fraction of second we can easily open the bottle, okay, cap of the bottle. So the machines or the devices which are making our work easier and faster are known as machines, and the machines which are manually handled, which we are handling in order to work on it, and the machine which contain only one or few moving parts, that is known as simple machines. Okay, next we are having what are complex machine. In the other hand we are having complex machine also, but in our chapter or in our syllabus only we are having just simple machines. But yes, we will see the definition of complex machine. Okay, so complex machine, as a name suggests, complex machines in which two or more simple machines work together. Means for example we are having wall clock, means here in wall clock two or more simple machines are combined together in order to move this wall clock. So this wall clock is regarded as complex machine. In a similar manner we are having bicycle. Here in bicycle also we are having more than one simple machine. So this bicycle is also regarded as complex machine. In a similar manner we are having washing machine. Many are there which are regarded as complex machine. Okay, in a complex machine two or more simple machines are combined together in an one object. Fine. Next we are having some functions of a simple machine. In this chapter, as we are going to study only about the simple machine, so firstly we will discuss about the functions of simple machine, that how simple machine are helping in our daily life. So first we are having a machine multiplies force. For example, when you are going somewhere on a road trip and all, in between the road trip the tire of the car is punctured and you want to change the tire. So how you will change the tire? Firstly, you will pick the car by your hand, by your muscular force, then you can change the tire. Like this you are doing? No, obviously no. We are using here one kind of machine known as screw jack. Here one kind of machine is there which this person is using. This is a screw jack which is ordered to lift the car up, and by using the screw jack, firstly we will lift the car up, afterward we will change the tire. So what is happening here? Actually here we are using a simple machine. This screw jack we are using, it is a simple machine. Means here we are applying very less force in order to move this machine, but this machine is lifting very much higher force. Means it multiplies our force. For example, if here I am applying 10 Newton force in order to move this screw jack, this screw jack is lifting up, for example, 500 Newton object or 500 Newton force it is applying on an car. Okay, means it is multiplying our force, and this is a function of simple machine. This is a beauty of simple machine, how it is going to help us. Okay. Next, we are having a machine help to change the direction of force. For example, if you are standing in front of a well and you want to take the bucket up from the well, okay, what you are doing? We are not just making our hand down and we are picking up the bucket. No, here we are using one kind of simple machine called pulley. One by one we will discuss all this kind of simple machine, don't worry, but here just see the example of pulley. Here in this case we are using a pulley in order to lift the bucket up from the well. What we are doing here, see carefully. Actually, if you want to apply your force on the handle of bucket and you will take it up, it is very difficult to do like this. Okay, so what we are using? We are using here pulley. In a pulley, one rope is attached. Actually, we are just pulling the rope toward ourselves in a downward direction. By pulling it toward ourselves, bucket is coming in a upward direction. Means by applying force in a downward direction, bucket is coming in a upward direction. Means with the help of machine we are changing the direction of force. We are applying in a downward direction force, but here bucket is coming in a upward direction. So it is a very simple to change the direction with the help of machine. Next, we are having a machine change the speed. Means in a bicycle, the speed of the moving wheel is different from the speed with which we can rotate the pedals. Means the pedals we are applying very little force, and with the help of little force these pedals are moving, but the speed of these wheels, these big wheels, are very much less as compared to the force which we are applying on the paddles. Means these paddles now here are acting like a simple machine which is making our work easier and faster, and we can change the speed with the help of machine. Next function of simple machine we are having, a machine makes the force to act at some desired point. Means for example, while cutting a paper or while cutting a cloth, we are using a pair of scissors. Okay, so in order to cut a cloth, firstly we are applying force on the hands of the scissor. Okay, we are applying force on the hands of scissor, but what this scissor is doing? Scissor is applying force on a paper by this long arms. Means by applying the force or by the machine, with the help of machine, you can make the force to act at some desired point. Okay, we can simply make the force. Means we are applying force here on these hands, but here cutting of paper is going to done with the help of these long arms. Means with the help of simple machine we are just changing the desired point. Okay. Next, we are having fifth function of simple machine. A machine enable us to do dangerous work. Means in order, for example, we want to burn the substance in this fire. Okay, by just using your fingers and putting into this fire, it is very difficult or unsafe work in order to do this. Okay, but in order to do this unsafe or dangerous work, we are using this kind of simple machine known as fire tongs. This is a fire tongs which help us or which enable us to burn this material or burn this substance in a fire. So this simple machine is making our work easier. This is a simple machine. Fine. Next, we are having terms related to a simple machine. So in order to learn the simple machine, firstly some basic terms are there that we should know first, and how to use that term. See carefully what are that terms. First, we are having effort. So what do you mean by effort? In order to use any machine, firstly we have to apply some force on that machine so that machine can do work. Okay, by simply just sitting on one a place, the machine cannot do its work. Fine. We have to go on machine, we have to work, we have to apply some force on that machine. So this force applied by us on the machine is known as effort. Fine. And next term we are having load. Load means it is a force exerted by the machine on an object. Means now after applying our work, after applying our force, what this machine is applying force on an object or this load in order to lift it up or whatever it want to do, the force exerted by the machine on an object is known as load. Okay. Term related to simple machine is fulcrum. So what do you mean by fulcrum? It is a fixed point. It is a fixed point about which this simple machine is going to rotate while doing work. This fixed point is known as fulcrum. Okay. Next point we are having mechanical advantage. What do you mean by mechanical advantage? Actually, mechanical advantage is a ratio of load over effort. Means load over effort means what? Load we have learned now only. Load is a force exerted by machine on an object. So what the force is acting by machine on an object over what the force we are applying on the machine in order to do that work. This is a ratio of these two terms. So these two terms is a ratio called mechanical advantage. So here we are having definition of mechanical advantage. So mechanical advantage is measured by the ratio of load over effort. Mechanical advantage is equals to load over effort. Next we are having SI units. As we know, load is what? Load is a force applied by machine on an object. So in short, load is a force. And what is the SI unit of force? SI unit of force is Newton. In the same way, SI unit of load is also Newton because load is also a force, kind of force. Next we are having SI unit of effort. As we know, what is an effort? Effort means whatsoever force we are applying on the machine in order to work it, that is known as effort. Okay. So effort is also a force applied. Force SI unit is Newton, means effort SI unit is also Newton. If you talk about the mechanical advantage, SI unit of mechanical advantage is load over effort. What is the SI unit of load? Newton. What is the SI unit of effort? Newton. So Newton will cancel each other, means mechanical advantage is having no units. Okay. Next important term related to simple machine is input. So what do you mean by input? See carefully. Input is a work done on machine. In order to move this machine, whatsoever work we are doing on machine, that is known as input, or you can also say like this, energy supplied to the machine. And but don't get confused in effort and input. Actually in effort I told that whatsoever force we are applying on the machine. Force means, effort means force, we are applying force. Force means push or pull to an object. Push or pull to any object is known as force. But here in case of input I am saying work done on machine. Work done means what? Work done means force multiply distance. Means how much force we are applying on machine and how much distance it is moving. Okay. So work done means force multiply distance, and force, simple force means push or pull to an object. Next important term related to simple machine we are having output. So what do you mean by output? Output is the useful work done by machine on an object. Means how much work this machine is showing on an object in order to do the work, that is known as output. And second definition you can learn like this also, energy imparted by the machine on the object, that is known as output. Next important term related to a simple machine we are having efficiency of a machine. So what do you mean by efficiency of a machine? Efficiency of machine is defined as the ratio of work done by the machine on the load, which is also known as output. So it is the ratio of output over work done by us on the machine, or you can say input. Okay. So efficiency is having the formula output over input. If you want to calculate the efficiency percentage, so efficiency percentage formula is output over input multiply 100. This you can simply learn also. Fine, this is known as efficiency of a machine. Next we are going to study about the types of simple machine. So here in this chapter we are going to study about the 6 types of simple machine. First we are having lever. Second we are having inclined plane. This is a form of inclined plane. Then we are going to study about wedge. This is a wedge formation of a simple machine. Then we are going to study about pulley. This is a kind of pulley. Then we are having screw. This is a screw. Then at last we are going to study about wheel and axle. So in this chapter in detail we are going to study about all these 6 types of simple machine. So let us start with the first simple machine, that is lever. So what do you mean by lever? Actually in this lever is a rod. Here this kind of rod is there which moves freely. This rod is going to move freely about a fixed point, and this fixed point about which rod is going to move freely is known as fulcrum. This is known as fulcrum, or you can say pivot point. Pivot point means the fixed point about which this rod is going to move. Fine. And at the one end we are going to apply some effort. Here at the one end we are going to apply some effort, and here we are going to use the load. In order to raise any load, we are using here some load. Here we are applying some kind of effort, and here in center we are having a fulcrum or pivot point. Fine. Then afterwards we are having the weight to be moved. Means, for example, with this lever, whatsoever weight you want to move, that weight that you want to move is called load. This is a load. Okay. Or the resistance. Load, other name is resistance, and the force applied on the lever. Means, as I already told, simple machines are not going to work by themselves. Okay, we have to apply some kind of force on it, and in order to move this lever also we have to apply some kind of force on the lever, and the force applied on lever is known as effort. Means on one end we are going to apply some kind of force, and on the other end simple machine is going to do some work, that is known as, this is known as simple machine's work, or this is a function of lever. Okay. Next we are having the distance between the fulcrum from the point at which effort is applied. This distance between the effort applied and the fulcrum, this distance is known as effort arm. And the distance between the fulcrum and the load, this distance is known as load arm. Find the distance between the fulcrum and the effort arm, and the effort is known as effort arm, and the distance between the fulcrum and load is load arm. Definitions clear, no? Next we are having principle of lever. On which principle, on which function lever is going to work? Actually principle of lever is a turning effect of force. So what do you mean by turning effect of force? Actually turning effect of force, you will study this concept in class 8. Properly you will study in that class. But yes, in this class I will tell you something about turning effect of force. Turning effect of force means whenever we are applying force to any object. For example, in this lever I am going to apply the force here on this effort point. Okay, so whatsoever force we are applying on any object, on that object which is pivoted or which is fixed at one point, that object start rotating about a fixed point. If I take the example of door, in a case of door, when we are going to apply the force on a handle of the door, means when we are applying the force on the handle of door start turning or start rotating about the fixed point, about this fixed point. So this turning, if this movement of force about a fixed point is known as turning effect of force. Okay, and this states that turning effect of force at fulcrum should be turning effect of force at load. Means whatsoever the turning effect of force is there at effort point, same kind of turning effect will be there at load point also, at the load arm also. Okay, so this principle we are having, effort into effort arm, means this effort multiply effort arm is equals to load into load arms. If you are not understanding that much about the turning effect of force, no problem, just learn this formula. Actually this formula is important for the principle of a lever, that is effort into effort arm is equals to load into load arm. This kind of formula we are going to use in order to solve the numericals also, so you have to remember this formula. Fine. Next we are having mechanical advantage of a lever. So as we know, mechanical advantage is actually a ratio of load over effort. In order to calculate the mechanical advantage, actually mechanical advantage means how much advantage we are getting from the simple machine. Okay, how much simple machine is helping us, that is a mechanical advantage. And in order to calculate the mechanical advantage, we are using the simple formula, that is load over effort. Means what force that simple machine is applying on the load or on the means the object, and what force we are applying on the simple machine, ratio is known as mechanical advantage. So next we are having this formula, mechanical advantage is equals to load over effort. So mechanical advantage of a lever. So in order to calculate the mechanical advantage of lever, we are having formula like this. Mechanical advantage is equals to effort arm over load arm. So how this formula came, see carefully. Actually in the before slide only we have discussed about principle of the lever. So what is the principle of lever? That is effort into effort arm is equals to load into load arm. We have studied this only, na? I will write the properly here. Effort into effort arm is equals to load into load arm. This only we have studied in the principle of lever, and here we want to calculate the mechanical advantage, which is nothing but a load upon effort. Means this effort is in multiply, that can I take this effort to that side, it will go in a divide sign. So here effort arm is same in this formula, effort arm is same here, is equal to same, load is same, multiply load arm is same. Okay, only just effort is in multiply, that side it will go in divide. Fine. So here you can see this load arm is in multiply, that side it will go in divide. So it will be effort arm over load arm is equals to load over effort. Fine. And as we know, load over effort is what? Load over effort means mechanical advantage. So mechanical advantage of lever is equals to effort arm over load arm. From this derivation, this formula came. If you understood this derivation, that is very good. But if you not understood, no problem. Just learn this formula. Mechanical advantage is equals to effort arm over load arm, which you are going to use in the numericals also. Fine. Mechanical advantage simple is load over effort, but in a case of lever, we are having effort arm over load arm. Next we are having types of lever. So in this class we are going to study about the three kinds of lever. First is first class lever. In a first class lever, here same, in all class levers same arrangement will be there, only the difference between the arrangement of the load, effort and fulcrum. So in a first class lever we are having a rigid rod which is going to support at some fixed point. Fine, and this fixed point is known as fulcrum. Just learn from this. Actually we are having three kinds of lever. I will tell you one by one. First we are having first class lever, then we are having second class lever, then we are having third class lever. See carefully how to learn these diagrams. You have to learn like this. Flea. F-L-E. Flea. Flea means in first class lever you have to take fulcrum in center. F means fulcrum. In second class lever you have to take load in center. And in third class lever you have to take effort in center. This rigid rod will be same in all three classes of lever, but only the arrangement of fulcrum, load and effort is there. Fine. So Flea formula you have to learn. Flea, first in fulcrum is there, in second class load is there, and in third class effort is there in the center. Now what about the other two ends? So in the other two ends, first in first class lever it is simple, means at one end effort is there and one end load is there, or you can rearrange also, here effort or here load. Okay, means fulcrum is in center and effort and load are on other ends. That is simple. Fine. In a second class lever and third class lever you have to remember that this fulcrum you have to take on left hand side only. Fulcrum you will take in left hand side only, and in second class load is in center, then obviously effort will be at last. Similarly in third class lever, effort is in center, fulcrum I told you have to take in at left side only. So what is left? You are left with load. So obviously load is at the right side. So like this you can learn the arrangement of the first, second and third class lever, and one by one we are going to discuss why these arrangements are like this. Fine. So first we are having first class lever. First class lever means when the fulcrum of a lever lies between load and effort. Okay, when the fulcrum is in between load and effort, that kind of lever is known as first class lever. So actually in this case, see carefully. This fulcrum is here and this is effort arm, means distance between effort and fulcrum is effort arm, and distance between fulcrum and load is load arm. So in a first class lever, in all cases effort arm is more, this effort arm is more as compared to load arm. But yes, in some cases in first class liver, effort arm is also equals to load arm. Means in some cases fulcrum is in exact center, effort is here, load is here, then effort arm is approximately equals to load arm. Fine. But in some cases of first class liver, we are having effort arm greater than load arm. Fine. Next, we are having examples related to the first class liver. For example, first we are having beam balance. So in a case of beam balance, this is a kind of beam balance. Here we are having a fixed point. Around fixed point, these two weights are going to move. This fixed point is known as fulcrum. Fine. And normally at the left side, we are using the weights. Here we are using the weight, means weight is nothing but a effort applied. Whatever weights we are using, standard weight that we are keeping in the left hand side, so here will be effort, and here we are calculating the load, means whatsoever material we have to calculate, we are keeping it here. So here we are having a load. So see carefully what is happening here. Actually here fulcrum is in center, effort and load are on other side. So this is which class liver? First class liver. Fine. Similarly, we are having a second example with seesaw. In a seesaw, see carefully, this is a fixed point around which these two boys are going to rotate, okay, or these two cartoons are going to rotate. So this fixed point is in center. Here we are having effort, here we are having load, or you can change also, this is a load or this is a effort, no problem. So fulcrum is in center, load and effort are on sides, means it is a first class liver. Means whatsoever example is coming for you, you have to just check the arrangement. Wherever the objects are kept, or wherever the fulcrum, load and effort is kept, by watching that you can just clearly know which kind of lever is there. Fine. Next we are having with a pair of scissor. In a pair of scissors, see carefully, around this fixed point this scissor is going to rotate or move. Okay, this fixed point is known as fulcrum, and we are going to apply force here on the hands of scissor. So here wherever we are going to apply force on a machine, that is known as effort, and here we are having load, means here we are going to put a piece of paper or cloth in order to cut it. So here we are having a load. So you can see carefully, you can see properly that fulcrum is in center, load and effort are on side. So scissor is which class liver? Scissor is first class liver. Fine. Next we are having second class liver. So as I told the formula Flea, according to Flea, second class liver, load should be in center. So here same, load is in center. So when the load on a lever lies between fulcrum and effort, that kind of lever is known as second class lever. So in a second class lever, see carefully, here we are having fulcrum, here we are having load, and as we know, distance between the load and fulcrum is called load arm. This is load arm, and distance between the fulcrum and effort is effort arm. This is effort arm. Fine. So see carefully, in a second class lever, effort arm is longer as compared to load arm. Okay. So see carefully, I will tell you the mechanical advantage also. Actually here mechanical advantage formula is effort arm over load arm. Okay, mechanical advantage formula we have studied only that, effort arm over load arm. See carefully in second class lever, as you can see, effort arm is more as compared to load arm, means effort arm is longer. If effort arm is more, then mechanical advantage is also more than or greater than 1. Fine. Just see the first class lever also. In first class lever, see carefully. In a first class lever, actually in somewhat cases, effort arm is taken longer as compared to load arm. If effort arm is taken longer than load arm, then mechanical advantage will be what? Mechanical advantage is effort arm over load arm. If effort arm is more, means mechanical advantage is greater than 1. But in some cases in first class lever, effort arm is exactly equals to load arm. So here mechanical advantage is what? Mechanical advantage is 1. If effort arm and load arm are approximately same, then mechanical advantage is 1. But if effort arm is greater than load arm, in that case mechanical advantage is greater than 1. Fine. Next we are going to start with the examples of second class lever. So firstly I will draw the basic diagram for second class lever. Basic diagram for second class lever is like this. Here in this case, load is in center, fulcrum is on side and effort is on side. Okay. So in a case of second class lever, first we are having the example of a door. So in a case of door, what we are having? In a case of door, from here, from the handle, we are applying the force in order to move the door. So this is acting like a effort, okay? And these are the fixed point about which door is going to rotate, and this fixed point is called fulcrum. And full-fledged door is acting like a load. So see from this diagram, and see from this diagram, compare it. Here we are having fulcrum, here we are having load, and here we are having effort. Means in between fulcrum and effort we are having a load. So this door is acting like a second class lever. Next example related to second class lever is bottle opener. So in a case of bottle opener, what we are doing, in order to open the cap of the bottle, we are applying the cap here, means load we are attaching here in center. So this is known as load, okay? And we are applying force from here. This part where from where we are applying the force is known as effort, and this is a fixed point about which that bottle opener is going to move. This fixed point is known as fulcrum. So in between fulcrum and effort we are having a load. So this is an example of second class lever. We are having third class lever. So in a third class lever we are having like this. As you know the formula, FLE, F-L-E. E means in a third class lever, effort is in center between fulcrum and load. So in between fulcrum and load we are having effort. This kind of lever is known as third class lever. In a third class lever, see carefully, fulcrum is here and effort is here. So distance between fulcrum and effort is effort arm, and distance between fulcrum and load is load arm. So properly from the diagram you can see clearly, you can see that load arm is greater than effort arm. And as we know mechanical advantage formula, mechanical advantage is equals to effort arm over load arm, okay? And here load arm is greater and mechanical and effort arm is less. If effort arm is less, means mechanical advantage is also less. Less than what? Less than 1. Mechanical advantage is less than 1 in a third class lever. Fine. And what is the use of this mechanical advantage equals to 1 greater than 1? Actually here in this case, as we have studied in a first class lever, mechanical advantage is equals to 1. Equals to 1 means whatsoever effort we are applying on the body or on the simple machine, same kind of work that simple machine is also going to do. Same kind of force that simple machine is also going to apply on the load. This is a means of mechanical advantage is equals to 1. In a second class lever, we have learned that mechanical advantage is greater than 1. What do you mean by this? Actually, mechanical advantage means effort over load over effort. Mechanical advantage greater than 1 means whatsoever work we are going to apply or whatsoever effort or force we are going to apply on a simple machine, in return machine is going to show us more force on the load. So mechanical advantage greater than 1 means more and more kind of force simple machine is going to show in order to move up or in order to take the object, okay? And in third class lever, mechanical advantage is less than 1. Mechanical advantage is less than 1 means we are applying more and more force on the effort, but simple machine is not showing that much force on the load. That is why in a third class lever, mechanical advantage is less than 1. Fine. Next we are having third class lever examples. First we are having sugar tongs. So in a case of sugar tongs, this is a third class lever. Firstly I am going to draw the diagram for third class lever. In a third class lever, F-L-E, FLE means effort is in center, fulcrum is always on left side and load is here. Fine. So here see carefully, here we are having a fulcrum, means about this fixed point this sugar tong is going to move. This is a fulcrum. Here we are going to apply the load, means from here only we are going to pick up the sugar. Fine. This is a load, and in between here we are going to apply the force. This is known as effort. So see carefully, effort is in center. Effort is in center means this is which kind lever? It is third class lever, okay? Next we are having similar example of fire tongs. In a fire tongs also, here we are having a fixed point, that is a fulcrum. Here we are going to apply force. From these points we are going to apply the force. So it is a effort, and here we are going to put some kind of load in order to move it or in order to use it. That is a load, okay? So here effort is in center. When effort is in center, we are having it as third class lever. Fine. Similar example we are having with a fishing rod. So in a case of fishing rod also, what we are having in first case, here we are having a fixed point, here we are having a fulcrum, sorry, here this is a fulcrum about which fixed this fishing rod is going to move, and here we are applying the effort on this means handle, we are going to apply the effort, this is the effort, and from here we are going to pick up the load, this is a load. So here you can clearly see that effort is in center. When effort is in center, this is which class lever? It is a third class lever. Fine. Next we are having numericals related to lever. So firstly write the formulas of the lever. First formula we are having mechanical advantage is equals to load over effort. Second formula we are having mechanical advantage is equals to effort arm over load arm. These two numericals, these two formulas we are going to use in order to solve the numericals. So see carefully, first numerical. The load arm of a lever is 10 centimeter. We are given with load arm. Just write load arm is equals to 10 centimeter and effort arm is this, and effort arm is given 40 centimeter. Okay. What is the mechanical advantage of a lever? So mechanical advantage of a lever we have to calculate. And as you can see from these formulas, effort arm and load arm is given. So which formula you will apply? First or second? Yes, you will apply the second formula. So what does second formula is? Second formula is mechanical advantage is equals to effort arm over load arm. Fine. So what is the value of effort arm? That is 40 over what is the value of load arm? 10. So 0 cut with 0, we are having mechanical advantage is equals to 4. And what is the unit of mechanical advantage? Tell me the unit. Mechanical advantage is having no unit. Why? Because effort arm and load arm both are in centimeter. Here also centimeter, here also centimeter. Centimeter will cut with each other. So we are having no unit of mechanical advantage. Simple mechanical advantage is equals to 4. Next we are having second numerical related to this. So second numerical we are having the load arm of an idle lever is 20 centimeter long. So load arm we are given with 20 centimeter and its effort arm is 1 meter long. Effort arm we are given with 1 meter long. How much load it can be lifted? How much load? Means load we have to calculate by using an effort of 40 Newton and we are given with effort is equals to 40 Newton. Firstly I will write the formulas here. First formula we are having mechanical advantage is equals to load over effort. Second formula of mechanical advantage we are having effort arm over load arm. Fine. See carefully here, effort arm is in centimeter. Sorry, load arm is in centimeter and effort arm is in meter. Firstly convert the both units into a single unit. I will convert this meter into a centimeter, which is easy to convert. So 1 meter is equals to how many centimeter? 1 meter is equals to 100 centimeter. So 1 meter means here you can write 100 centimeter. Fine. Now see the formula. In order to calculate the load, what we will do? Means they are not given to solve with mechanical advantage. They told us to solve with the load. We have to calculate the load. So which formula I will apply? I'm not getting how I will apply the formula. So third thing we are having with the principle of lever. Third formula I will tell you the same which we have studied in the previous slide also. That is effort into effort arm is equals to load into load arm, which is nothing but a principle of lever. Fine. So we will apply this formula. Why? Because we are given with effort, we are given with effort arm. We have to find load, we are given with load arm. So we are going to use this formula. So write it here. Effort into effort arm is equals to load into load arm. Means according to conditions we will see which formula we are going to apply. So effort is what? Effort is 40 Newton. Now you will see that it is in centimeter and here effort is in Newton. How this? Actually effort is a force applied by us on the machine. So force applied, we know force is a Newton only. Force SI unit is Newton and this is load arm and effort arm. Arm means distance. Distance should be in centimeter. So it is units are given right. Fine. Effort arm is given what? 100 is equals to load is given. We have to calculate. Multiply load arm is given 20. So as you have to calculate load, we have to take this 20 to that side. 20 is in multiply, that side it will go in divide. So here we will see 40 multiply 100 is same is equal to load is same. 20 is in multiply, that side it will go in divide. Cut 0 with 0, 2 ones are 2, 2 2s are 4, 20 will be there. So here load will be 200 Newton. Load means force applied by machine on an object, that is a load. So load is a 20 Newton. Fine. Next we are going to study about the second kind of simple machine, that is a inclined plane. So what do you mean by inclined plane? Actually inclined plane is a sloping surface. This kind of sloping surface we are having which help us to make our work easier. Might be you have also seen this kind of inclined plane or sloping surface at your house or in a front of hospitals. Fine. So using an inclined plane, we can easily raise a heavy load. Means if you want to raise this can on this jeep, just applying your force, applying your muscular force and taking it up and putting into the car, it is very difficult. Okay. But we can make our work easier by using this inclined plane. Just use this inclined plane and apply little force. So by applying little force, it will move up and it will go into the car or jeep. Okay, so this is an inclined plane which makes our work easier and faster. How? It can easily raise a heavy load into a certain height, up to a certain height. So this inclined plane act as a simple machine. So whatsoever things which make our work easier and faster, like this inclined plane is making our work easier and faster, this inclined plane is nothing but a simple machine. Plus it is help to multiply force also. What do you mean by multiply force? Means even though applying less force, we are going to raise a very heavy load. Okay, so it is going to multiply our force. Fine. Next we are having an inclined plane is used at various places. Might be you have seen these kind of examples at your home also. Means in a front of home, ramp is provided. Why ramp is provided at the main gate of the house? To push up the scooters or motorcycle or bicycles into the house. By using this kind of ramp, we can easily push up the scooters, motorcycle into the house by using an inclined plane or a simple machine. Next we are having in front of hospitals. So ramps are provided in the hospital so that wheelchairs or stretchers can easily move into the hospital by even though applying less force. Next we are having, this is your favorite example, playground slide. So might be now you are going to link it with your daily life. The playground slide is also another example of inclined plane. Means by applying even though less force, you are coming with a more force here. Okay. So next kind of simple machine we are having a wedge. So wedge is also a simple machine in which two or more inclined planes are there. How inclined planes are there? See carefully. Here one, this inclined plane is there. Second, this inclined plane is there. And this is also acting like a inclined plane. Means wedge is that simple machine where two or more inclined planes are tapered together or means fixed together to form a sharp edge. Here two or more simple machine or two or more inclined planes are combined together to make a sharp edge or a pointed edge. And this wedge is generally used in order to split or purse material. Purse is also means to split the materials into two halves. So in order to cut the material into two halves, we are using this kind of wedge. Fine. So for example of wedge like knife, axes, plough, iron nails, these all are the examples of wedge where you can easily see that two or more kind of inclined planes are joined so that it can easily like cut the materials into two halves or it can easily make the materials to move together. Okay. So the basic principle of the wedge is to reduce the surface area. Actually what we are doing in a case of wedge, by using two inclined plane, at one point we are decreasing the surface area. Whenever we are decreasing the surface area, might be you are knowing this formula or no, I don't know. Formula is pressure is equals to force over area. This is the formula we are having for pressure. If we are having an object of very less area, that object will apply more and more pressure into any object. Even though by applying small effort or small force on that object will move with a more pressure. Fine. So this is a basic criteria. Means if you want to cut this log, we are using a For example, knife or X we are using, axis we are using, fine. In a axis, actually we are having a very reduced surface area. Reduced surface area means this X will produce more and more pressure in a wood log, and it will cut the wood or split the wood log into two pieces. So the basic principle is behind this. We will reduce the surface area of the wedge in order to increase the pressure on any object. Next type of simple machine we are going to study, that is a pulley. So what do you mean by a pulley? Pulley is a simple machine. Pulley is also a simple machine which is commonly used to lift up a heavy loads. So in order to lift up a heavy loads, by applying our muscular force in order to lift this heavy load, it is very difficult to do this task, fine. So by using this pulley, we can easily lift up a load by applying small effort or small force, fine. So this is a pulley. The arrangement of pulley is like this. A pulley is a flat metallic or wooden circular disc which is having one groove on it. Means on a pulley, this on a circular disc, one groove is there. Groove means hollow surface is there. On this hollow surface, one rope is attached. One end of the rope is going to, on the one end of the rope we are going to apply effort, and on the other end of the rope we are going to lift up the load, fine. Next we are having rope passes through the groove. From this groove, from this hollow surface, rope is going to pass. This kind of pulley you can see inside this hollow surface is there. So from this hollow surface, rope is going to pass like this. The pulley is capable of rotating the central axis. Means this pulley can rotate about its central axis. This fixed point is known as axle, about which the pulley is going to rotate, and axle is also attached to some rigid support. Okay, here at a rigid support axle is attached, and around the axle, about the axle, this pulley is going to rotate. Next we are having kinds of pulley. So pulley are of two kinds. First we are having fixed pulley, second we are having movable pulley. As the name suggests, fixed pulley is that pulley in which this circular disc or this pulley is fixed at some point. Okay, so here rope is there, here also rope is attached, means from the one end we are going to apply effort, and from the other end load is going to raise up. And second type of pulley is movable pulley. As the name suggests, movable pulley means in this kind of pulley is going to move about a fixed point or about this. Okay, in order to raise up a load, pulley is going to move itself. Next we are having the simplest form of pulley which we are using in our daily life, or which you have also seen might be near the well, that is known as single fixed pulley. Okay, so in this pulley, this axle is attached to a rigid support, and this rigid support is known as block. This is the axle around which circular disc is going to rotate, and this fixed point at which axle is going to attach, that is known as block. Next we are having, when we are applying force downward, whenever we are applying the force to the downward direction from one side of the rope, so means we are using our force in order to make the effort. So by applying our force, here weight is going to come outside, or weight is going to move upside. So thus we can easily pull the weight by applying a little effort. Another form of pulley is single movable pulley. This is the arrangement of single movable pulley. In this type of pulley, one end of the rope is attached to the fixed point, means one end of the rope is attached to a fixed rigid support, and the effort is applied on the other end of the rope. Here also two ropes are there, but one rope is actually attached here to the block, fine, and one end of the rope, here we have to apply the effort. Whenever we are applying effort here from this side, whatsoever pulley is there, that full-fledged pulley is going to move upside, and the load is attached to the pulley. This load is attached to the pulley, and when we apply the effort from here, this pulley start moving upside. With the help of pulley, load will also move in the upward direction. And the means more this explanation of the single movable pulley you will study in the higher classes. In this class you are having this much only arrangement and how it is working, fine. Next we are having a combination of fixed and movable pulley help to pull much more heavier load. If we are having much more heavier load by using single movable pulley, then also we are not able to move up. By using fixed pulley, then also we are not able to move up. So in that case we are using a combination of fixed as well as movable pulley in order to lift a very heavy load. Okay, this is the arrangement of fixed and movable pulley. So fixed pulley, in a single fixed pulley is used to lift a bucket full of water. Means might be you have seen in a well that bucket full of water, we are going to apply a force in the upward direction. That bucket can come easily from a well by using a single fixed pulley. Okay, but in other hand, if we are talking about the cranes are lifting very much heavy loads. Okay, so in a crane we are using the combination of two or more pulleys, or in a combination of fixed and movable pulley. Fine. So in order to lift up very heavy load, we are using crane, and in order to lift up small load, we are using a single movable pulley or single fixed pulley. Fine. Next, we are having numericals related to pulley. So see carefully the first numerical. A pulley can raise a load of 100 kg. So load is given, load value is given 100 kg by applying an effort equals to 20 kg. So effort is given 20 kg. What is the mechanical advantage? Mechanical advantage we have to calculate. I will tell you the formula again one time, that what is the formula for the mechanical advantage. Mechanical advantage formula is load over effort, or one formula also we are having effort arm over load arm. Okay, if in any numerical we are having effort arm or load arm, that in that numerical we will use this formula. Otherwise, if we are having load and effort, we will use first formula. Fine. So see the formula carefully. We are having mechanical advantage is equals to load over effort. So what is the value of load? Load is 100 kg over effort is what? 20 kg. So 0 cut with 0, 2 ones are 2, 5 twos are 10. So mechanical advantage is 5. What is the unit of mechanical advantage? No. Mechanical advantage is having no unit. Fine. Next, we are having Charles apply an effort of 20 Newton. So effort we are given with 40 Newton. Charles apply an effort of 40 Newton. So effort we are given with 40 Newton on a simple machine through a distance of 0.5 meter. Means on a simple machine, whatsoever this simple machine is there, he is applying effort of 40 Newton. So this distance is given. This distance is nothing but a effort arm. Effort arm is given 0.5 meter and is able to push a load of 100 Newton. So he is able to push a load of 100 Newton through a distance of 10 centimeter. So load and distance is given, means load arm is given, that is 10 centimeter. Firstly, convert this 10 centimeter into meter. Why? Because upside you can see carefully that effort is in Newton, effort arm is in meter. So here also it should be same, that is load in Newton and load arm in a meter. So convert into a meter. As we know, in 1 centimeter, 1 by 100 meters are there. Fine. So 10 by 100 meter, that is 0.1 meter. So we have to calculate input, output and efficiency of a Charles. Okay, so what do you mean by input? Actually, might be you have knowing that formula, that effort into effort arm is equals to load into load arm, principle of lever. Actually, in this case, effort into effort arm is nothing but input and load into load arm is nothing but output. So from here you can see the formula. Input is equals to effort into effort arm. This is a formula of input. So just put the values of effort and effort arm. So input will be, effort is what? Effort is 40. Multiply effort arm is what? That is 0.5. Solve it, you will get input is equals to 40 multiply 5 by 10. 0 cut with 0. You will get 20 joule. Fine. And here we are going to calculate the output. Output formula is what? Output is load into load arm. So load is given, we are with 100. Multiply load arm is given 0.1. So solve it. 100 multiply 1 by 10, that is 10 joule. So output is 10 joule. Input we have found, output we have found. Now the work is efficiency. So what is the formula of efficiency? Efficiency means output over input. So what is the value of output? That is 10. What is the value of input? That is 20. So efficiency is 0 cut with 0, that is 0.5. Or in efficiency percentage you can write 0.5 multiply 100, that is 50% is the efficiency. Fine. Next type of simple machine we are going to study, that is a screw. So screw is also a simple machine which appears like a nail. Means in a screw it appears like a nail, but it is having a spiraling groove made on a curved surface. In this curved surface, spiraling grooves are there. Might be this you are watching here, these grooves are there. Okay, and whenever on a nail grooves are there, that is known as, or spiraling grooves are there, that is known as screw. Okay, so a screw consists of a threaded steel. Actually, in this screw, threaded steel is there. One end of the rod is made narrow. One end of the rod of this screw is made narrow and pointed. And this edges and this end is narrow and pointed is called tip of the screw. This is known as tip of the screw. The end of the screw which is made narrow and pointed, that is known as tip of the screw, and the other end which is made flat, that end is known as head of the screw. Head and tip is clear to you. The broad area of the screw is known as head and the narrow and pointed area of the screw is known as tip. Next we are having, when a screw makes one complete rotation, it advances a distance equal to space between two consecutive threads. Means whenever the screw is going to complete one rotation, means whenever we are going to push the screw into a wall, whenever we are applying force from here, okay, in a rotational form we are applying the force. So whenever this screw is going to complete its one rotation means what? That one rotation is equal to the distance between these two threads. Actually, these are the threads. Whenever this screw is going to complete its one rotation, whenever we are applying force from the outside, that one rotation, that one complete rotation is exactly equal to the distance between, or the space between, the two consecutive thread. And this distance between the two consecutive thread is known as pitch of a screw. This is known as pitch of a screw. Next, we are having common uses of screw arrangement. So, screw arrangements are used to fit the doors in a door frame. Whenever you want to fit the door into a door frame, you are using these kind of screw. Might be you have seen this. Whenever hole is there, we are going to put the screw into it, and from the outside we are applying the force. Whenever we are applying the force, it is going to move inside, and finally it will look like this. Okay, so screw arrangement is used to fit the doors in a door frame. Next, we are having common uses of screw arrangement. A cork screw is used to pull out the cork from a sealed bottle. Actually, this is a form of corkscrew. This corkscrew is used to take the cork out from a sealed bottle. Means when you want to take the cork out from the sealed bottle, by applying our force by our hand, it is not possible to take it out. So we are using this kind of corkscrew. So with this corkscrew, we can easily pull out the cork from the sealed bottle. And a bit of an electrical drilling machine is a screw. Here also, in this case, in a drilling machine also we are using a screw, and it is used to make the hole in a hard surface. By using a drill, in a drill screw arrangement is there. Whenever we are applying force from the outside, it is going to move inside into the wall or into the hard surface. So it will make a hole into a hard surface. Next we are having nut and bolt. Nut and bolt is also a pair of is also an example of pair of screw in which nut is just rotate over the threaded bolt. This is a bolt, full-fledged, this is a bolt, and this is a nut. Whenever you want to move the nut inside the bolt, then also we are applying the force, and that nut is going to rotate over the threaded bolt. Okay. Then we are having a screw jack. So screw jack, this one which is used to lift up the heavy materials or heavy cars, vehicles. Okay, this screw jack is also a nut and bolt arrangement. In the screw jack also we are having nut and bolt arrangement in which nut is attached on the threaded bolt. Fine. Then arrangement of simple machine. Next 6 we are going to study, that is wheel and axle. So wheel and axle is an arrangement of wheel. Actually here wheel and axle, first we are having wheel. This wheel is attached to one fixed sport that is known as axle. This is a wheel, and this fixed sport in between might be you are watching, that is a axle. Okay. The arrangement help in moving a heavy load. Might be you are knowing in a cars also or on a heavy loads also, these wheel we are using. These kind of wheel we are using in order to move anything. So by applying even though less effort on a heavy load, we can easily move a heavy load with the help of wheel and axle. In a car also, in an automobile also, we are using wheel and axle arrangement. So here we are having a wheel. this circular part we are having a wheel, and this fixed point about which wheel is going to rotate, that fixed point is known as axle. Next, we are having a wheel and axle arrangement consists of two cylinders of different diameter. How two cylinders? See carefully. First, we are having this one. In between two wheels, one cylinder we are having, and here also this circular path is a cylindral form. Actually, cylinder is in this form, like this. This is a form of cylinder. So this is a cylinder, this is also a cylinder. Means in a wheel and axle arrangement, we are having two cylinders but with a different diameters. As you can see carefully, see clearly that in this wheel, larger diameter is there, and in this cylinder we are having larger diameter, and in this cylinder we are having smaller diameter. And the cylinder of bigger diameter is known as wheel. This cylinder of bigger diameter is known as wheel, and the cylinder of smaller diameter is known as axle. If definition of wheel and axle will come in exam, then you have to write like this. Okay. Next, we are having examples related to wheel and axle. So first example related to wheel and axle, we are having bicycle pedal. So in a case of bicycle pedal, actually what we are doing here we are having two circular wheels. These paddles here in the paddle, so two circular wheels are there, and in between two circular wheel, this axle is there. Means whenever we are rotating the paddle with one paddle, second paddle is also rotating with the help of this axle. Okay. Second example related to this wheel and axle is steering wheel. In a case of car, this steering wheel is attached to the tire of the car with the help of one axle. Okay, this is steering wheel is also a wheel, and tire of a car is also a wheel, and in between we are having axle. So this is a wheel and axle arrangement. So what is happening here? Actually in this case, whenever we are rotating the steering of the car, by rotating the steering of car, this axle is also rotating. With this wheel, this axle is also rotating, and whenever this axle is rotating, it is also rotating the tire of the car. Means by applying the force on the steering, we can easily change the direction, or we can easily change the movement of the tire. Next, we are having knob of water tap. In a knob of water tap also, we are having wheel and axle arrangement. Here also, whenever we are rotating it, actually this is a circular, and here we are having axle. Okay, wheel and axle is there, which can easily rotate a tap. Next, we are having care of machine. Means now we have studied about the 6 kinds of machine, simple machine which we are using in our daily life. As we know, machines are making our work easier and faster. Means with applying even though less effort, we can use it very comfortably. We can lift up heavy loads. We can use it very properly. Okay, but in order to use this machine, we should care these machines also. So here we are going to discuss some of the points how to take care of your machines. So first we are having iron parts of machine should be painted to prevent from rusting. Whatsoever machines we are having, in that machine, if any iron part is there, that iron part should be painted frequently, so that iron should be prevented from rusting. So what do you mean by rusting? Rusting means whenever iron is coming in contact with the oxygen or moisture or water, it will form iron oxide layer, Fe2O3 dot X molecules of water, which is a rust. Okay, so whenever iron is coming in contact with moisture, it will form the iron oxide, or we can say rust it is going to form, and this rust will slowly eat up the metal surface. So in order to prevent from the rust, we are using the paint in order to reduce it. Next, we are having in order to minimize the friction. In order to minimize the friction in the moving part of vehicles, we are giving the oil or lubricant we are giving to the moving parts of the machine, so it can reduce the noise and wear and tear in the machinery parts. Next, we are having it is desirable to adjust the moving parts of machine from time to time. If you will see that yes, now my bicycle or now my car is not working properly, then you should take that bicycle or automobile to the care center, so that they can properly they can adjust the moving part by using some formulas and all. Okay, so it is desirable to adjust the moving parts from time to time. Next, we are having machine should be regularly cleaned. Means if you having a bicycle or you're having any simple kind machine in your house, that machine should be cleaned after regular intervals of time. Even though, for example, you're having an automobile, that should be go in a service center, that person can service it properly and it should be maintained properly. whenever not in a use, whenever our machinery parts are not in use, for example our car is not, we are not moving, we are not using it that many much, so that car should be covered, or that machinery parts or any simple machine should be covered properly so that it will not affect by any dust particles. So write in the chat box how you are taking care of your machine in your daily life. Okay, so this is all about your chapter number 4th, that is energy simple machine of class 6th ICSE. If you like the video, please like it, share it and subscribe to Jatin's Academy. Thank you so much.